Hello everyone, Quentin from Drive System Design. I'm still working from home during the lockdown, but I'm also still working on our internal research project, which is the software and the hardware for our internal motor control platform. So last time I gave you an overview of what we could do with our software, Simulink API, the one to set up all the peripherals and set up the microcontroller. And on the next few videos, I wanted to focus on individual peripherals or modules and what you can do with them and how easy it is to set them up. So today we're going to have a look at the GTM, generic timer module. There's one in every CPU, though the name might change, but what they're used for is to generate PWM signals. And so they can do other things, but you also might be wondering what's a PWM signal and what do you do with it. So let me go smaller. You don't need to see me for this. So here's a PWM signal. So it's just a signal you turn on and off a certain amount of time per second. That's the frequency, and you control how long. That's the duty, and you use it to control your electric motors. So you want to ask a torque or a speed to your motor, and the motor control software will generate the right PWM signal. So you have your motor, and you have your IGBTs that are set up in the three-phase half-bridge configuration. You have your battery, and then here you have all the control signals from the CPU that are calculated by the control software. That's pretty much it. That is very important. And so we're going to have a look at how we set it up with our interface and how easy it is to use. So let's start with going back to Simulink. So here we have our initialization function like before. And then, so to start, we initialize the timer module. Then we give it a frequency that we here put 5 kilohertz. Can be whatever you want, almost whatever you want. But you can also change it during runtime, which is very useful. And here you have the block that we use to update the PWM duties. So we have 6 switches. So you have your 6 outputs, 6 inputs to the function, and then for each switch you have the T on and T off time. So if you go back to this, you select T on, T off, so that you have full control over your signal. So that's it. Once again, very easy. It's all set up already, and then I'm going to show you how you use that in real life. So I've created another piece of software, initialization here. Here we have acquisition of a CAN signal and do some math on the duties I acquire to generate the T on and T off times, and then here updating the PWM. I'm going to show you my setup to see what we're going to do. So I have this is a digital scope from Sealy, the Logic Pro, that I use because we have 6 signals to look at, so it's a lot easier. Here you have interface board that I use with a mess of wire just to have an interface, a control board with the software and the CAN communications. Back to here. Right. So here I've got bus masters set up to send a CAN message, and here I have my digital scope. So acquired a signal. So now it's set up as we called center aligned. All the PWM signals are aligned in the center, and that's the typical signals you'd send for motor control. So here you go, you see phase A, phase B, phase C, and the signal are complementary. I'm not going to go through motor control software again, but this is complementary, so that only one switch is on at the same time, else you create a short circuit, and you want the current to go through the motor and back through the ground. So here I can lower the duty to see that it's working in real time, send the message, press start, and here I've got very small duty, 6%. But as we have full control, we can do other things. If you want to control something else, you might want to do what we call edged aligned. So here all the signals, instead of being centered, they are starting on the same side. Here's the left edge aligned. So if you control LEDs, for example, that might be something that you want to use. Here with a larger duty. Here we go. Same signals, but aligned differently because we have full control over the GTM. So yeah, that's it. It was super easy once again, but that means that our engineers, they don't have to worry about the hardware. They can just set up things very quickly and worry about the motor control software, which is the important part. So we can do other things with the GTM, but I don't think we're gonna have to look at this in another videos because, for example, you use the GTM to trigger your current conversion, so that you measure the current that's going through your motors at the same time, and you can also trigger a task. So usually you trigger a task at the 50% of your duty, so that you trigger the calculation of your motor control software. So that's it. So I hope you learned something today once again, and we'll see you at the next one. See ya.